Alright, today we're going to look at lesson 9.3 in your textbook, and this is on solving systems by elimination. So we're going to look at how to add and subtract two equations together to eliminate one of the variables. Alright, this is task 1 if you want to follow along. To eliminate something means to get rid of it. The elimination method for solving a system of two equations eliminates one variable in the system by adding or subtracting the equations. Steps in elimination. Add or subtract the equations in the system to eliminate one variable, and then solve for the variable that was not eliminated. Subtract the value of the variable you found into either original equation and solve for the other variable. Write the solution as an ordered pair. Consider the following system of equations. X plus y equals 4 and x minus y equals 2. Without actually graphing, how do you know that the graphs of the two equations in the system intersect at a single point? Complete the explanation. The slope of this and the slope. Alright, so remember to find the slope. You can simply have it in point slope form. Let me find my pen. Alright, so if we have x plus y equals 4, we can quickly subtract the x to the other side, so y equals negative x plus 4. So we can see that the slope, y equals mx plus b, is negative 1. For the other equation, we can just move the y to the other side. So we can do x equals y plus 2, move the 2 over, so y equals x minus 2. The slope here is 1. So you can quickly see the slope is negative 1 and positive 1. Alright, so the slope of x plus 4 is negative 1, and the slope of x minus y equals 1. So the lines are not parallel. If they had the same slope, they'd be parallel and they would not intersect. If they have different slopes, that means they will eventually intersect. Alright, the graph of the system is shown. Using the graph, complete the statement about the solution of the system. The solution is, okay, so we know the solution is the intersection point. So we know it's going to be 3, 1. You always do x first, and then y. 3, 1. Alright, so it says use the system to complete the statements. The sum of the left side of the two equations is... Alright, so if I add the left side of these two equations, I'm going to get 2x. My y's are going to cancel. So this is going to be just 2x. And the sum of the right side of the two equations, the right side is 4 plus 2, or 6. Alright, why are these sums equal? Alright, these sums are equal because if I'm just adding consistently all the way across, I'm just using properties of equality to solve that equation. Alright, equate the two systems from part C and solve for x, then substitute the value of x into either original equation. Alright, so if we have 2x equals 6, because that's what happens when we did this right here, when we added these together. So when we added these, we got the 2x, this canceled, and we got equals 6. So 2x equals 6, divide by 2, x equals 3. So we know that x equals 3, and then we could plug that back in and find y as well. X equals 3. If we substitute that back in, we're going to get y equals 1. And you can look back up at one of the equations and see x plus y, if we let one of those be 3, subtract 3, you get 1. So y equals 1. And then what do you notice about the value of x and y that you obtain? Well, we know that those are the solutions of the equation. We already looked at the graph and found the intersection point to be 3, 1, so that's one way to solve it. And then elimination is the other way to solve it, and we got 3, 1 in both cases. Alright, now use a similar process to once again solve for x and y, but this time subtract each side of the second equation from the corresponding side. Okay, so that's basically the same thing. We're going to skip through that. Let's see. All right, here's a different system. Consider the systems. Choose the option that best completes the statement. You blank, add or subtract the equations to eliminate a variable. All right, so we have 2x and 4x, 3y and y. So we cannot just add or subtract the equations. We have to multiply by something first. All right, in order to eliminate a variable by directly adding or subtracting the equations, the coefficients, remember, are the numbers in front of the variables, coefficients of one of the variables must be the same or opposite. If they're the opposite, you would add. If they're the same, you would subtract. Okay? All right, so that's all for task 1. If you have questions, let me know. All right, this is 9.3, task 2. Solve linear systems using elimination. You can solve a linear system by subtracting or adding to eliminate a variable, provided that the coefficients of the variable you want to eliminate are the same or opposite. Use elimination to solve the system. All right, so let's go ahead and look at this system of equations here. All right, so we have 7x plus 2y equals 4. And we have 3x plus 2y equals 12. All right, so since we have, this 2 looks kind of funny here. Since we have 7 and 3, that's not going to help us much, but we have 2 and 2. So if we add 2 and 2, that's 4. But if we subtract 2 from 2, we get 0. So to eliminate, we want one of our variables to go away. So what I can do is subtract one equation from the other equation. So when I subtract, I'm going to subtract everything across here. So I'm going to change every sign there to subtraction. So 7 minus 3 is 4x. 2 minus 2 cancels. And 4 minus 12 is negative 8. And then I divide by 4. X equals negative 2. All right, so you can see they did the same thing here, but they put the negative outside the parentheses. Remember, the parentheses tells you to distribute that negative, but I like to add it in my equation all the way across so that I don't forget. Like when I get over here, I don't want to forget to subtract because I would get a different or the wrong answer when I get there. So just be aware of that. All right, select the correct words and variables to complete the explanation. Why do you subtract the equations instead of adding? Okay, remember if we added, we would not have eliminated a variable. Adding the equations would not eliminate a variable. Subtracting the equations eliminates y because the coefficient of y is the same, different. They were opposites. Nope, they were the same. Coefficients of y were the same. They were both 2y when we looked at them. They were opposite once I added the negative. All right, so substitute negative 2 for x in either original equation and solve for y. All right, so you can see they took the equation 3x plus 2y equals 12. So they took the second equation, the original equation, and then they just substituted negative 2, which is what we found for x, in for x so they could solve for y. So 3 times negative 2 is negative 6. Then I'm going to add negative 6. I'm going to add 6 to the other side, gives me 18. Divide by 2, y equals 9. So x is negative 2, y is 9, so my solution is negative 2, 9. Would you get the same value of y if you substituted negative 2 for x in the first equation? Yes, you would. It doesn't matter which equation you substitute. Once you find one of the variables, you can substitute into whichever equation you think looks the easiest. All right, substitute negative 2 for x in the first equation and solve for y. So 7x plus 2y equals 12. They're just going to check it here. So 7 times negative 2. And then 7 times negative 2 is negative 14. And then they've got 2y here, so that means they've added 14 to the other side. 14 plus 4 is 18. And then divide both sides by 2, so you get 9. So it's the same thing we got using the other equation. All right, that's all for task 2. If you have any questions, please let me know.